Days become shorter in winter primarily due to Earth's axial tilt and its orbit around the Sun, a phenomenon that has occurred for billions of years. At the equinoxes, when days and nights are roughly equal, Earth is positioned so that its axis is neither directly nor inversely inclined toward the Sun. However, during summer solstices, occurring in June and December globally, the northern hemisphere or southern hemisphere is tilted most towards the Sun, resulting in longer days with less daylight to the opposite hemisphere. This seasonal shift causes variations in day length across different regions and latitudes throughout the year. The earliest evidence of seasonal changes influencing human behavior dates back to prehistoric times when hunter-gatherer societies relied on predictable patterns of light and darkness for resource allocation and survival strategies. With the advent of agriculture, the changing seasons became more critical as cultivation schedules were aligned with specific days or phases within lunar cycles. Over centuries, these cultural practices evolved into what we now recognize as calendars. Key developments include advancements in astronomical observation techniques, leading to more precise measurements of Earth's movements. For instance, Tycho Brahe's meticulous records from 1572 through 1600 allowed Johannes Kepler to deduce that planetary orbits were elliptical rather than circular and to formulate his laws of planetary motion based on these observations. In modern times, space missions have confirmed that Earth does indeed tilt about its polar axis by approximately 23.5 degrees relative to the orbital plane, causing seasonal variations. These changes in day length have significant impacts on various aspects of human life, including agriculture, energy consumption for heating and cooling, and cultural celebrations tied to seasons. In regions with longer winters like Siberia or northern Scandinavia, extended periods of darkness can affect mental health and circadian rhythms negatively. Conversely, increased daylight during summer solstices promotes vitamin D production in darker-skinned individuals. As global temperatures continue to rise due to climate change, the seasonal cycles may shift slightly. Models predict that Northern Hemisphere winters could become shorter by 10 days on average by mid-century, but with substantial regional variations. These projections underscore the complex interplay between natural cycles and anthropogenic influences on Earth's environment. To optimize this trend in understanding day length, fluctuations over time, incorporating technological advancements such as more accurate satellite-based observations and machine learning algorithms for predictive models could further refine our knowledge about these seasonal changes.